So if you are new to free prep hours, we pick a different theme every time. We have different instructors who do them, and we spend an hour on that theme. If you are new to the GRE, don't worry. Part of what we do today will be some foundational introductory stuff. I'll explain to you what you need to do the problems we're going to do tonight. If you're not new to the GRE, I'm also hoping we'll get into some kind of challenging, interesting quant problems tonight as well. So hopefully something for everyone, no matter where you are coming from. A lot of the problems we use in our session tonight are going to be drawn from this book, the 5-pound book of GRE Problems. It's an enormous resource, and if you're going to get 2 books to study for the GRE, I'd say get the official guide and then get this book, because it is all the practice problems you will need. You won't run out. So some of the problems tonight are drawn from here. A couple I think I made up for this session in particular. So what we're going to talk about tonight, we are going to talk about quantitative comparison questions. This is a type of quant question that only appears on the GRE. So I think it's one of the most important question types to talk about, because everyone who starts studying for the GRE, this is a new thing that they have to learn. You know, we've likely done standardized tests with reading comp or with sort of normal 5-question multiple choice before, but this is something you're only going to see on the GRE. So we're just going to talk a little bit about what these questions are, where they show up in the test, and then we're going to get into talking about our core strategies for approaching these, and hopefully cover most, if not all, of our core approaches to these tonight, starting with testing numbers, looking at algebra, looking at reasoning. Okay. Along the way, you guys are going to be solving problems. I'm going to be having you share things that you find or think about in the chat. So definitely be ready to engage and participate. And also, if you have questions, feel free to throw them into the chat. And I will hopefully catch all of them along the way. All right, so for those who are new, or maybe people who need a refresher, each quant section, and there are 2 quant sections on the test, is 35 minutes long and has 20 questions. And there are 3 types of quant questions that you're going to see. And we're going to have to do these fast, which we'll talk about in a sec. So this is what we're going to talk about tonight. We're going to talk about 7 quantitative comparison questions. So there's a lot of them. It's a little more than a third of a quant section. And I won't say too much more about them now, because we're going to talk about them for the rest of the hour. Half of each quant section will be what we call discrete quant. And these are your sort of regular multiple choice word problems type of questions. A few of them are text entry or select all that apply, but most of them are like what you see here, 5 answer choices. And then the remaining 3 questions in a section ask about graphs. So there's a graph or a pair of graphs in each of those sections. And you get asked 3 questions on the same graph or pair of graphs. I did a workshop on those a couple months ago, I think, not that long ago. I think it might be up on YouTube if you want to learn more about graph questions. All right, so just thinking about quickly how these questions show up in a quant section. We are going to start with 7 of these quantitative comparison questions. Then we're going to do 5 of our discrete quant, or sort of other types of multiple choice quant. Then we're going to do our 3 graph questions, which we call data interpretation, or DI. And then we're going to come back to this. So we're going to dive in to quantitative comparison. Just out of curiosity, if you could chat in, what concerns you most in quant? And it could be a specific question type, it could be a topic, it could be some other kind of skill. Yeah, geometry. I should do one of these on geometry-ish, because I love geometry, actually. It's like one of my favorite things to teach, and I don't think I've ever done a free prep hour on it. So yeah, select all. Those are definitely often harder. Those can often be a good one to skip. Yep. Just knowing all of our approaches. Cool. Hopefully, Amanda, I can help you to chip away at that tonight, because we're going to learn, hopefully, most of the approaches for these QC questions. Yep, word problems. I feel the love for that. There is also an old free prep hour on word problems that you might be able to look up on YouTube too. Cool. All right. Well, let's look at QC questions. Okay. So this is what you're going to get in a quantitative comparison question. You will always get a quantity A and a quantity B. And then you might also get some information up front. And we're going to talk a lot tonight about what we're going to do with that upfront info. Always, every QC question is asking you the same thing. It is asking you to compare these two quantities. That's always our task, compare. Super, super important. And we will always have the same 4 answer choices. Quantity A is greater, quantity B is greater, C, the two quantities are equal, and D, their relationship cannot be determined. So my guess is some of you who have been studying, you already have these answer choices down, you got them memorized. If you haven't, if you're new, I'm going to put these little symbol in the corner of each of my slides so that you can have this to remind you, okay, which answer choice do I pick now that I figured it out? And you'll have this cheat sheet. Now, unfortunately, QC questions are never going to be as easy as this question here. And that's maybe a really good first thing to know about these questions. They are never this obvious. And if they look obvious, there's probably a trick. And let's actually take a look at what I mean by that. They're never obvious. So let's say I gave you this question. What would the obvious answer here be? Like if we just rushed into making a snap judgment about this, what might we conclude? Oh yeah, that's really clear. That's obviously bigger. Yeah, yep. So if we were going really fast, or if we're sort of new to QC, we might say, oh yeah, x equals 2y. So I can go ahead and plug that in there for x. And then I'd see, oh yeah, 2y obviously looks like it should be greater. Like A looks obvious. And as soon as I see that in QC, like, oh, it looks so clear, I'm going to stop, I'm going to pause, and I'm going to think some more. So yeah, if I said, okay, if y equals 2, then quantity A would be 4, and quantity B would be 2. Ooh, yeah, that is a great point. I can use negative integers. The only restrictions I have in these problems are the information they give me up here. So if they don't say it has to be positive, then I don't have to use positive numbers. Yeah. And what happens if I plug in a negative number for y? Yeah. Yep. Yeah, exactly. Yeah. You guys are getting it. I like this. Yeah. So if I plug in -2 for y, 2 times -2 is -4. And now B is greater. And I love the all caps. Yeah. Awesome. So I see, okay, in this problem, sometimes it's one way, but sometimes it's another way. So it's not always going to be the case that A is greater. Something else might be true. And if I have 2 different cases, what answer should I go with? Like, oh, sometimes it's this, sometimes it's that. Yeah. Yep. Now I go with answer choice D. Cool. Ayush, to answer your question, we are not going to talk about reading comp tonight. There are some free prep hours on YouTube that do talk about reading comp, and we will do a reading comp one at some point in the next month or so. I think the next one I do will be either on geometry or reading comp, is my guess. Yeah, we only have an hour, so we unfortunately can't cover things comprehensively. Yeah, so here is the core. Here's the core process for QC. It's not going to be obvious. So we're going to need to test. We're going to need to test cases. When I'm testing cases, when I'm plugging in numbers, what am I trying to do? Like, what did I do here? What am I trying to do? If I say, okay, I know it's not obvious, I'm not going to jump to conclusions, I'm going to start testing some numbers. What's my goal? Yeah. Nice. Matt and Amanda, I like it. I want to eliminate. And ultimately, I want to see, can I prove D? After I tested y equals 2, what answers could I eliminate at this point? Like, what do I know just from testing that one number? can I rule out? Yeah, I know they're not always going to be equal. Yep. So at this point, I can rule out B and I can rule out C. And then I need to test another one to see, is it going to be A or is it going to be D? Okay. So let's try another one. You guys, I think you're ready. Go ahead, try this one on your own. I'll give you a little bit of time to think about it, maybe a minute, and then I'll ask you all to chat in. So don't chat in your answer right away. Wait until I ask for it. All right, so when you are ready, go ahead and chat in your answer. Yeah, okay, we're split between B and D. Cool. So let's think, let's test some numbers. What's a value for X that's going to give me this relationship? Where quantity B is greater. What could I plug in for X where that's going to be true? Yeah, I could plug in 3. I could plug in 2. So let's see, 3. And then just remembering something squared is 3 times 3. I get 9. 9 is definitely greater. Awesome. All right. So at this point, what answers can I rule out? If I have a case where B is greater. Yeah. Yep. I can see it's not going to be A. It's not going to be C. So we're down to B and D. Now, here's a question. Is there a number I could test that would give me this relationship? Ooh, yeah. Yep. X equals 1 or X equals 0. 2 good answers because 1 and then 1 squared also equals 1. Same with 0. Cool. So at this point, what answer have I proved? So if I've said, okay, sometimes it's this way, sometimes it's that way, yeah, yep, I can feel confident that my answer is D. Because there's no restrictions on what X can be here. They don't give me any restrictions up front. So I know any number I can test. So we're done. You know, on test day, we're done. But because we're learning, let's learn something more from this problem. What's a number I could test that gives me this relationship? Yeah. Yep. Yep. 1/2 squared, 1/2 times 1/2 is 1/4. And that's going to be smaller than 1/2. Now, I saw someone mention negatives, and just a quick reminder, if I plug in -1, what's -1 squared? Yeah. So while in our last problem, negative numbers were great numbers to test, here they end up not being as useful because they end up working the same way as those positive integers that we started out with. All right. So just to recap, what's one important thing to remember about QC questions? What's anything new or something you've learned that you want to emphasize? Yeah, they're not obvious. Yep, we want to pay attention to constraints. Yeah, I like that, Isaiah. It's too easy. Think more. And test cases. And so let's talk for a moment quickly about testing cases. We've seen that in a lot of these problems, what types of numbers tend to give us our obvious result? Like what were we testing where we were like, oh, obviously it's B? What types of numbers were we using there? Yeah, positive, integers. And remembering, if anyone needs math vocab, integers are just whole numbers, so numbers that aren't fractions or decimals. So I often start with those. I start with my obvious case. What types of numbers were we testing to get that second case, that case that allowed us to prove D? Yeah, negatives. Yep. What else were we testing? Zayas knows what's up. You guys have been studying. I love it. Yeah, fractions. And people are giving us a really cool acronym for remembering all of these. Yeah, we got 0. Cool. Just zone F. What does zone F stand for? Well, it's basically what we've listed here. Z is for 0. O is for 1, because we also saw that was helpful in the exponent problem. N is for negative. F is for fraction. And E is for extreme. And extreme just means something very large, or kind of at the outer bounds of what we're allowed to test. Extreme is probably the one we use least frequently. The others we use more. Yeah, so this, especially when you're starting out, is going to be super helpful. You might even write it on your paper as you're doing QC problems. So you remember, okay, it's not obvious. I'm going to pause. I'm going to think. I'm going to see if I can prove D, and I'm going to think of one of these numbers. So up to this point, someone also mentioned it's really important to look at restrictions, and we haven't looked at restrictions a whole lot yet. So I want to look at some problems with restrictions now. So we're continuing on in our world of testing numbers. We will get to some other ways to look at QC in a moment, but let's look at a problem that has some restrictions. Oh, this is not quite it. Here we go. There's a problem with some restrictions. So right off the bat, it shows up, I don't know if it shows up in our books. It shows up in a lot of our live teaching. So if you've come to a trial class or maybe watched other free prep hours or workshops that we've taught, that's probably, I think, where people have come across it. Oh yeah, and the blog. There's a lot of really good stuff on the blog too. So looking at our restrictions to this question, which of my zone F options can I not test here? Yes, Abuna, you are, and in fact, they do give you a calculator on the computer that you use. So you can use the calculator. It's not always helpful, but it is an option. All right, so back to my question. If these are my restrictions up front, yeah, I can't test negatives, I can't test 1, I can't test 0, and one other, yep, can't test fractions. Cool. So what's a number that we could test? Oh, yeah. So Jeanette, I think I threw you off because I said can't test negatives. And what I should have said is we have to test negatives. And so negatives aren't going to really be a weird case. Yeah, Ufoma, you also got my error. I was excited and going too fast. I have to use negatives. So I'm not going to be able to use them as like my odd second case. I'm going to have to start with them. Yep. So you are not losing your mind. I am making a mistake. So yeah, x equals -2. So -2 cubed is just going to be -2 times -2 times -2, which will be -8. And what's -2 to the 5th? Yeah, nice. -32. Awesome. Cool. So I've tested a case, and I have a case where a is greater. And now I'm going to pause and think. Do I need to test a second number? And if so, what number should I test? What do you guys think? Yeah, some people saying no. Why not? Yeah, yep. Yeah. This is the only kind of number I can test. I can only test negative integers. So all negative integers will behave the same. in this problem. You know, if I just multiply more negative numbers together, I'm going to get even more numbers. Yeah, and Kundai made a great point. They're odd exponents, and I know odd exponents with a negative number, I'm always going to get a negative. And if that's feels like, oh God, exponents, that might be a good place to start. Exponent rules are super important if you're thinking about reviewing math content. Cool, so this version of this problem, I actually only really need to test one case. Because I see, okay, I don't have other options to prove D with. I just have this, and so I can see, all right, it's gonna be A. What about if I change my restrictions though? Let's look at a slightly different version of this problem. Try this one. I'm gonna give you guys a minute or so to try this one on your own, and then we'll see what answer we get. You can chat, but maybe chat just me. So send the chat just to all panelists. So you can answer if you're ready. All right, everyone go ahead and chat. If you were going to answer this right now, what are your options? Or what would you pick? Cool, yeah. All right, so now we're split between C and D. Awesome, so let's think about what's going on here. X is an integer, so it can't be a fraction or decimal, and it's between -2 and 2. So what numbers am I allowed to test here for X? Yeah. Yep. I can test -1, I can test 0, and I can test 1. So here I only have 3 options. So I'm going to want to check all of those 3 options to see, do I get 2 different cases or not? So if I test X equals 1, well, 1 cubed. Ooh, yeah, Lindsay, why can't I test 1.5? Yeah. Nope, you are not dumb. It is the mistake that the GRE is a very clever test, and it's trying to trick us. And one of the reasons we're talking about restrictions right now is they try to trick us by putting a lot of restrictions and we miss one. So it's a good mistake to make because now you're alert to that and you will not make that mistake again. So mistakes are great and not stupid. They're what we learn from. Cool. Yeah, 0 in both counts. And what about -1? Yeah, Isaiah is right. -1 cubed, well, that's still -1. -1 to the 5th, that's also still -1. So actually in all 3 cases here, these are going to be equal. Our answer is C. Does anyone have questions? Or alternatively, how is this problem trying to trick us? Yeah, we have to know our facts. Like we have to know how exponents work. We have to know what these definitions mean as well. That's definitely part of it. Flashcards are great. Keep a stack of flashcards with you. Put the math facts on them as you study. That's a really great way to just get that content solid. and exponent rules too. And as we're seeing, like having those content foundations is important. Yeah. Ooh, and Hyundai has a good point too. Here, they're saying greater than and less than -2 and 2. So that doesn't include -2 and 2. If I were going to draw this on a number line, I might draw it like this. So I'm not including those points. I'm just including. That is a really good question, Isaiah. I'm gonna think about it a little bit actually, and I'm gonna circle back to it maybe toward the end because I want to think about a good, concise way to give you advice on that. But it's a great question. So I just want to add something to our list of important things with QC. Or maybe not add, but emphasize. Pay attention to the constraints. We just saw 2 questions that had the same quantities, but the constraints were different, and that gave us different answers. So a super important thing about QC. Okay. So we've talked a bit about testing numbers. We've talked a bit about what types of numbers to test. We've seen some traps. I want to now start looking at a second way that we might approach a QC question. Because not every QC question is about testing numbers. There are some other approaches that we use. So I want to look at this question. Now I check out my question, I note my restriction, and I see, okay, I have a restriction up front. I know Z is greater than 2. And so I could just say, all right, I'm going to pick a number for Z. Like let's say Z equals 3. And I am going to just plug that into these expressions and see what happens. And that is a fine and valid way to do this problem. Nothing wrong with that. However, I have, some arithmetic to do. These aren't the most straightforward quantities. And for me personally, I make a lot of arithmetic mistakes. I always have. It's one of my big, big struggles with these tests. So for me, for this problem, there's another technique that I might use here. I'm going to do some algebra, and I'm going to do some algebra with the goal of just simplifying these quantities, of making these quantities change from what they are now into something that's a lot easier to plug into. So I'm curious, does anyone know that strategy or have a sense of what might I do if I was going to do some algebra here? Yeah. Yep. Yeah. So Mad says, yeah. And Isaiah's saying something very similar, saying like, okay, treat A and B like an inequality. And then Isaiah says, oh, if we have the same thing on both sides, we can cancel it out. And I'm going to explain a moment about why that is. So Sean had a nice suggestion, which is to put a box with a question mark here. And this box is here to remind me of 2 things. The first is that this question is asking me, how does quantity A relate to quantity B? I'm not necessarily being asked to calculate exactly what quantity A or quantity B is. I'm just comparing them. There is a relationship between these, right? Like one could be greater, there could be an inequality, they could be equal. So they do exist in a relationship. I just don't know what that is. And that question mark is there to remind me that I don't know what that relationship is. But what I do know is that I can treat this, I can pretend this is an equation or an inequality. I can say like, okay, if they were an inequality or an equation, well, I could do the same thing to both sides. And I could do the same thing to both sides because when I do that, I'm keeping the relationship between the 2 sides the same. So Isaiah said, well, if something is the same on both sides, we can cancel it out. Like if I have Z cubed here and Z cubed here, I can cancel that out because it's going to have the same impact on both sides. So it's kind of irrelevant to my comparison. What else could I do? If I wanted to keep going, sort of pretending that I'm working with an equation here, like if this were an equation, yeah, I can add 4Z to both sides. Because I'm doing the same thing to both sides. I'm not changing the relationship. But now, after I do that, I'm going to have something that looks a little nicer. Right? Like instead of having Z's on both sides, now I just have Z on one. Yeah. And Sean, I can keep going and add 3 to both sides. and I get 11z here and 11. I could even divide both sides by 11, and I'd get z here and 1 here. What do I need to do now? Yeah. Yep. Exactly. So I do algebra first, and then I check restraints. Yeah, exactly, Conlin. I know that z is greater than 2, so z is definitely greater than 1, because they tell me z is greater than 2. So I do my algebra, and when I do the algebra, I'm not solving for what z is. I'm just simplifying both sides. So I'm saying, okay, my new quantity A is here. My new quantity B is here. And I can immediately see. Yeah, Ufoma, you could plug in right away. Like you could just plug into these expressions. That's totally fine way to do this problem. It will be posted on YouTube. So yeah, it will be up on YouTube. And I think they might send you that link when it comes up. Not totally sure. But sometimes I like to do the algebra first before I plug in, because then it makes that plugging in step super, super fast and easy. Yeah, I think for me, because my arithmetic is a weak spot, it's going to make it faster. Yeah, and for me, more accurate. If you are someone who is less psyched about algebra, maybe this is a problem where you'd plug in right away. There are some problems, though, where this is definitely going to make your life a lot easier. So it is a really important technique to know. Though using it on this particular problem, I think could slightly be a matter of taste. Let's try another problem that we can use. Here, I don't really need to deal with zone F. Why? Why is this not a zone F problem? Yeah. Yeah. I check the restrictions. So Matt, they tell me up front z is greater than 2. So it's similar to that last one we saw with the x is less than -1. Like that rules out most of my zone F options. So if I were going to plug in a number, I would plug in like z equals 3, probably, and test that. And so when I get to this point where I check the constraints on the problem, or for some reason I think I was trying to write both constraints and restrictions and came up with restraints. Then I'd say like, okay, well, z, the smallest z could be would be like 2.1, and that's still going to be greater than 1. So that's sort of the way I would think about plugging in here. Let's try another one. I want you guys to try out this idea. Try out this strategy of doing the same thing on both sides here. See how it goes. I'll give you a minute or so. You can chat just me the answer if you get it, or wait until I call for everyone to chat it. All right, everyone chat me. What, if you had to answer right now, what would you answer? Cool. Yeah, so let's take a moment here to talk about our I was like constrictions, restraints. It's just there's like 5 words I'm sticking together tonight. Let's talk about our restrictions or constraints or restrictions. Seems to be what I'm saying. Gustavo has Y cars, so I know Y represents cars. So what does that tell me Y has to be? Yeah, or 0. It could have 0 cars. Has to be greater. And what else? It tells me something else about what Y is and isn't. Y is or is not. Yeah, Kundai, an integer. Yep. So whenever you see physical things like cars, houses, people, like if it would be really difficult or really disturbing to divide it into parts, it has to be an integer and probably has to be positive. Temperature is the only physical quantity that you might see a negative amount of on the test, including money. I don't think they deal with negative amounts of money. Okay, so I know minimum value for Y here is 0. So what can I do if I'm going to now do some algebra with my quantities? Yeah, I can add 6 to both sides. So same thing, I'm just grouping my numbers, I'm grouping my variables. What do I do next? Yep, get rid of that 4y. So I have 2y and I have -2. I could divide both by 2. So I get y here and I get -1 here. And now I come back to my central question. How does y compare to -1? Well, if y, minimum value for y is 0, y definitely has to be greater than -1. And A was our answer, which a lot of people got to. Super psyched about. I'm guessing maybe some people missed the restriction or missed that hidden restriction, which is why we are doing this problem, in part to point out that sometimes those restrictions are a little sneaky in how they're presented. Are there other things that tripped people up here? Is there something about the algebra technique that anyone is finding tricky or confusing? Has a question about? Yeah, so this is like a sample problem that we made up to illustrate this point. And I would say this is kind of on the like medium easy side. GRE like, but on the sort of lighter side, essentially. Though not without its tricks. Yeah, Samiksha, same as with, would be nice. You can do these operations in any order. Like you could start by subtracting 4y, you could start by dividing by 2. You have a lot of flexibility in doing that. All right, let's try another one. I actually want to talk about this for a second before we dive in. Yes, I might. That's a good point. I might use it with more than one unknown, especially if I thought there was a way I could like eliminate a variable or, simplify that situation. Yeah, for sure. If I see 2 variables in a QC question, I'm almost always going to try and find some kind of algebra to do first before I plug in. Great question. Yeah, so this one I want to actually talk about together because I think there's some tricky stuff in it. So I could plug in right away. What's going to happen if I do that? Like, I'm like, okay, x doesn't equal 0, so I'm going to test a negative. I'm going to test a fraction. I'm going to test 2. What's going to happen if I go down that road? Yeah, I'm going to have to deal with fractions and decimals in a big way. And it's going to take me forever. I have to cube things and double them and subtract them and divide them and multiply them. Like there's a lot going on. So for this problem, when I see algebra this complex, I am going to immediately try to simplify with algebra. So I see complex algebra. I'm going to simplify with algebra. Now, I have a lot going on here. So I'm going to just focus on one part first. That's generally true when these problems start to get complicated. Like pick one small part, focus on it, go from there. So let's just look at quantity A. I'm actually going to physically block out quantity B so it doesn't distract you. Let's just look at quantity A. Now, I have one fraction and it's divided by another fraction minus another. What part of this big complicated mess do I want to start with? Like, do I want to do the subtraction first, do division first? Sean says denominator. Do other people agree? Yeah. We want to start here. We want to start with a denominator. If I have addition or subtraction in part of a fraction, I want to clear that out first. So I want to get rid of the subtraction. Then I'll start dealing with the division. So I'm going to even block out our numerator here for a moment so we can just focus on our denominator. Okay. I have 2 over x squared minus x over x cubed. I have 2 fractions. Can I simplify either of those fractions? Let's start with that. Yeah. Yep. I can simplify this. And if that didn't pop out to you, I sometimes find it helpful to just remind myself of what is really going on with exponents. It's just this over 3x is multiplied together. So I can cancel this x out with 1 down here. Yep, you guys are got it. It's 1 over x squared. So now in my denominator, I have 2 over x squared minus 1 over x squared. What does that equal? Yeah, same. 1. 2 minus 1 is 1. Keep the denominator, 1 over x squared. So now I've replaced this whole denominator. I've simplified it down to 1 over x squared. So now let's bring back our numerator. I'm dividing 3 over x by 1 over x squared. What do I do when I divide fractions? If I were going to write it this way. Yeah, I flip the denominator and multiplier. I multiply by the reciprocal. Yep. I actually don't need to make it negative. I just keep it as the reciprocal. Yep. So I have 3 over x times x squared over 1. And for me on the GRE, I think it's super important when you multiply fractions to always cancel first before you multiply. So I can cancel an x here with an x here, and I get 3x. So I have now turned this whole nightmare mess into something much simpler, into 3x. That is my new quantity A. Go ahead and see if you can do the same thing with quantity B. When you get it, send a chat just to me with what you get. If you aren't sure, you get stuck along the way, you can chat me too. I can hopefully help you out. But everyone go ahead, simplify the algebra in quantity B, send a chat just to me with what you get. All right, if you haven't yet, go ahead and chat what you have. Cool. I like it. I'm seeing lots of correct math. Yeah, just really quickly, I can cancel this x here, get x squared. 3 minus 1 is 2, so I have 2 over x squared. I flip that to multiply. I can cancel, cancel. And as many of you got, I also get 3x. And awesome, I have 3x in quantity A, I have 3x in quantity B. Those are exactly the same. So my answer to this question is C. The two quantities are definitely equal. So we actually didn't even have to test numbers here. We just had to do algebra. That's pretty cool. And by doing algebra, we saved ourselves what I think would have been a nightmare of plugging in numbers. So some QC questions, we're going to plug in numbers. Some QC questions, we might end up doing algebra. Some we might end up doing a combination of both. So my question is, when? What might we see in a problem that would make us think, oh, let's test numbers? No, we actually, free prep hours in general, we theme toward either quant or verbal because we only have an hour, and it's hard to cover much on either. But my guess is the next free prep hour that either I or my colleague do will be verbal themed. And you can always send in questions to suggest particular verbal topics if there's things you'd like to see. Let's come back to the question I asked. What might I see in a question where I think, okay, I'm going to test some numbers. I'm going to test some cases here. Yeah, not sort of simpler quantities. Some, but not too many constraints. Nice. So there's like some flexibility in what it might test. The quantities are simpler. Sometimes if it looks easier. So plugging in numbers can also be good if you're just really stuck too. That's the flip side. Sometimes if you're like, I don't know what to do, then just testing numbers can be a place to start. Now, what might I see where I decide to use algebra? I'd say like, I'm going to do some algebra first. Yeah. Complex comparisons, quantities. Yep. Lots of variables. Cool. What we just did here is, I think, actually one of the most important things you can do when you study. So you solve problems, you think about how would I solve this problem? How would I solve that problem? And then you take a moment to step back and ask, okay, so what in this problem told me that I should use that strategy? What did I see here that said, oh, this is what I should do? And if you can train that, like these types of problems, I go this way, those types of problems, I go that way, it's going to make you so much more efficient and accurate. You're going to get better at working with this test a lot faster. So I actually think what we just did is like one of the things you always want to do when you study. And you can actually train this with flashcards. I think a great way to make flashcards is actually to use this format to say, okay, if I see this, like if I see complex algebra in my quantities, then on the back, I should do this. I should do the same thing to both sides, or I should find an algebraic way of simplifying. And that's really helpful. Um, cool. Isaiah, I'll circle back to that problem at the very end and I'll show you that, but I haven't forgotten anything. Yeah, Matt, I wouldn't write the whole problem itself, though I might make like notes on the restrictions or simpler versions of the quantities, but I would write down all of my scratch work. So actually what I've been writing on screen, I try to make what I write on screen close to what I would write on the test. The more I write down, the less error prone I am. Though I don't copy down the whole problem, and in part for that reason. Yeah. I want to look at one more because we've seen testing numbers, we've seen algebra, and I want to just point out that sometimes we do something a little bit different. These aren't the only two pathways. So I want to look at one last problem. Now, this problem looks super, super complicated up front, I think. The quantities look really messy. But if I notice the right things here, I can actually make this problem really fast. So just take a moment and look at it and think, is there anything you notice here that might be useful? Yeah, there's definitely something going on with the exponents. And with the plus one. Yep. So we've seen something tonight, right? We saw some problems that had x cubed. And we saw when I had a negative number cubed, it was always going to be negative. And that's generally true. Any negative number to an odd exponent is always going to be negative. And the opposite is that any negative number to an even exponent is always going to be positive. So a lot of people are saying, oh, I notice these exponents. Like I notice I have 2n over here, and I have 2n plus 1 over here. And I notice that I have negatives on both sides. What do I know about 2n? Anything times 2. Does anyone know a useful fact about that? Yeah, it's always going to be even. Because even numbers are multiples of 2. So anything times 2 is always going to be even. So here I have a negative to an even number. What's this whole quantity A going to be in terms of sign? Not necessarily even. So a negative number to an even exponent is always positive. So -1, like -1 squared or -1 to the 4th, it's always going to be positive. And then 63 is also positive. So I have a positive times a positive. And that's going to give me a positive. Now, what about quantity B? 2n plus 1. If 2n is even, 2n plus 1 is going to be, yeah. Like evens and odds alternate on a number line. So if I start with an even and I shift 1 up, I'm going to get an odd. And I know that a negative number to an odd exponent is going to be what? Yeah, it's going to be negative. So in quantity B, I have 7 to the n, which is positive, times a negative. And that's going to give me a negative. So if quantity A is always positive and quantity B is always negative, what's my answer? Yeah, my answer is A. And I get there without having to plug in numbers and also without having to do algebra. So some QC problems we can do just by noticing certain patterns and training ourselves some. Yeah, it's cool. And there's a bunch that can be done like this by kind of noticing important things and going from there. This is also where I think making those types of flashcards is really, really helpful to sort of say like, okay, what are the patterns that I notice here? All right, we are almost out of time. I want to take a couple minutes just to answer the really good question that Isaiah asked, which is how to get comfortable with quant mechanics and quant foundations. And then I want to sum up some of our takeaways for today. I'm going to come back to our list. And I'll just give you my thoughts on quant foundations. First, arithmetic. Get an app, play drills. There's something you can Google called ZetaMac that's a fun online arithmetic game. Get a times table app. Like get those sort of paper mental math stuff really fast. Because yes, there's a calculator, but it can slow you down, so you don't want to rely on it too much. Make your own flashcards. So every time you're kind of doing a problem or reading a book, and you see something you don't know, put it on a flashcard. In terms of learning concepts, there's lots of great books out there. I will say that the official guide itself has great problems, but their explanations of concepts are not my personal favorite. So lots of other great books. That one is a little maybe not as good for learning quant concept. There's a lot of good free resources online. Khan Academy, if you like more video explanations instead of book explanations, can be a great place to turn for learning concepts. There's so much on there, though. You just have to do some sifting to sort of find what you like. We also make a video product called Interact that you can try for free for a week, and that has a lot of great quant foundation stuff in it too. So you could try that for a week and sort of brush up on quant foundations with that, and then decide where to go from there. So those are my sort of core recommendations for quant foundation stuff. All right. Before we leave today, before we finish for the day, a really important thing to do when you study is to pause and sum up what you have learned at the end of each study session. So let's take a moment and do that. Everyone in the chat. ZetaMac, it's like a web page. I just forget the URL. I'll look it up now. But while I am doing that, everyone chat in what is one thing you learned today. And I will chat in this math game, arithmetic.zetamac.com. Yeah, don't get scared. Break it down one piece at a time. Use algebra to simplify. Learn patterns. Yeah, flashcards are great for that, for training that. Zone F. Oh, yes, Amanda, take a pause. Look at the problem. Decide the best strategy. It's great. Yeah, and that's a great point about QC too. Simplify is greater than solving. Compare instead of solve. Pause and choose a strategy. Zone F. Don't forget those cases. Break things down. Don't be scared. Yep. Look for patterns and learn them. Yeah, that's a cool problem. I like that one. QC is not obvious. I love that. What other did I miss? Yeah. Simplify with algebra. Yeah, it's a really good point. Focus on the comparison. You can do a lot of QC problems without ever knowing exactly what A and B are. Looks easy. Think more. Cool. Pay attention. Do restraints, constraints, restrictions. That's totally okay, Abuna. Lots of people start there. I work with students all the time who have not done math in years and come in and just need to spend a little bit of time with the math foundations. And if that's where you're at, that's totally normal. Another good suggestion is give yourself some time just to focus on the math foundations before you even worry about getting into the problems and strategies. So you might say, I'm going to take a few weeks just to brush up on my exponent rules and my algebra mechanics and my fraction mechanics and drill with that stuff first. And then I'll start bringing that into GRE level problems. But for sure, jumping right into sort of tough GRE problems when you're just not feeling comfortable with the quant foundations can be really frustrating. Lots of people start in that place too. So you might say, look, I'm going to focus on that for a little bit. Okay, that is our session. Thank you so much for being here on this lovely Monday night. Hope to see all of you in a future free prep hour. And if not, best of luck with your studies. One final thing I'll say is that if you are looking for other fun free resources, you can always take the first session of one of our courses for free, either in person if you live in a place where we offer those, or online. So that's another thing to check out. So happy it was helpful, and have a great